In this video, we're going to talk about the common logarithm, which is log base 10, to help you out with some of your 12.5 homework. All right, so our common log, if I write log of x, or log of any input, the base right here is base 10. All right. Remember what logs do. They take in powers of their base and spit out the exponent. So log, when it's left blank, right there, the base is 10. What's going in are powers of 10. Just like with any log, they're taking in powers of their base. They're snobs. They take in powers of their base and they spit out the exponent. All right, so we're going to simplify some log expressions here with our common log. Let's go for it. Log of 10. Well, log of 10 is log base 10 of 10. What does this do? It takes in a perfect power of 10 and it spits out the exponent. 10 is 10 to the 1. Right? That's what's going in. 10, which is 10 to the 1, is going in. What's going to come out? We're going to spit out the exponent. Answer? 1. This is asking me a question. 10 to what power is 10? 10 to the 1 is 10. Right? 10 to what power is 10? That's the equivalent exponential statement. Oh, 10 to the 1 is 10. The number that we're looking for here is 1. That's what the exponent is. All right, let's do a bunch more. Log of 0.01. Well, that's log base 10 of 0.01, and 0.01 is a perfect power of 10. 0.01 is 10 to the minus 1. It's a tenth. You can write a tenth, but I'm going to write it as 10 to the minus 1. Why? Log base 10 is gobbling up a perfect power of 10. What's it going to do? It's going to spit out the exponent. Answer? Minus 1. I'm going to box these answers. Done. Right. If we're writing the equivalent exponential statement, 10 to what power is 10 to the minus 1 is 0.1? That's the question. Oh. 10 to the minus 1, which is a tenth, that's 0.1. The number we're looking for here is minus 1, the exponent. Okay, let's do a few more. Log of square root of 10. That's log base 10 of square root of 10. Well, square root of 10 is a perfect power of 10. It's 10 to the 1/2 power. I'm gobbling up a perfect power of the base. I'm gobbling up a perfect power of 10. And I'm spitting out the exponent. Answer, 1/2. Done. Okay. I'm going to leave, if you want to write the equivalent exponential statement, you're more than welcome to do so. Log of 0.001. Well, this is log base 10 of 0.001. And that is a perfect power of 10. This is 10 to the minus third. Log base 10 is taking in a perfect power of 10, a perfect power of its base. All it's going to do is spit out the exponent. Answer, minus 3. Done. Okay. Log of 100,000. This is log base 10 of 100,000. It's asking me 10 to what power is 100,000? Oh, that's 10 to the 5th right there. Yeah. Log base 10 is taking in a perfect power of 10. All it's going to do is spit out the exponent. Answer, 5. The equivalent exponential statement is 10 to the 5th is 100,000. This can look very intimidating, which I don't blame you if you feel that way. But if you just keep coming back and say, what does a log do? It takes in a power of its base. So you got to pay attention to the base. Log base 10 takes in powers of 10, and it spits out the exponent, right? It's the opposite of, log base 10 of x is the opposite of 10 to the x. That exponential function and log function do and undo each other. All right, we got one more, and I'm going to do it 2 ways. One, you might notice that you can simplify the 5th root of 100,000. Why? Because 10 times itself 5 times is 100,000. This is the 5th root of 10 to the 5th. So if you notice that and just simplify here, oh my goodness, the 5th root of 10 to the 5th is just 10. So it's log base 10 of 10, which is 1. Right. Log base 10 takes in a perfect power of 10, and it spits out the exponent. The exponent here is 1. Okay, so beautiful, done. Perhaps, though, you would use this, write this as a fractional exponent and use our power property. That would be a perfectly fine way to simplify this. I want to do this problem again, just a different way. And we're going to get the same result. This works too. Log of the 5th root of 100,000 is log of 100,000 to the 5th power. All right, it's base 10. I just rewrote that root as a fractional exponent. Now using my power property, I can bring this guy down in front and have good old multiplication. A 5th times log base 10 of 100,000. Okay. We have a fifth times log base 10 of 100,000. Well, 100,000 is 10 to the fifth. All right. So what does log base 10 do? It's going to take in a perfect power of 10 and spit out the exponent. The exponent there is 5. So we have a fifth times 5, which is 1. 5/5 is 1, and we are done. Okay. Looking for my gray. I'm done. Okay. A little bit more work, because we didn't, on the first one, we did notice that we had a perfect power of 5 right there, and so we simplified first. But this is a great thing to do as well, just to kind of review using this power property. Okay, so that should help you with some of the questions in 12.5 where the common log base 10, shows up.